Hello, good morning for everyone. We will continue with the education track on the third day of the JupyterCon 2023. It's a big pleasure of mine to invite here, they are already here on stage, Denisa and Carlos, who will show us a little bit of Jupyter with Blockly, which I believe is a little bit inspired by now I forgot the name, a project from MIT where you scratch. Yeah, thank you very much to teaching programming. I'm really looking forward, and thank you for your talk.
Thank you. Hi, everyone. Thank you for joining us today, and we hope that you're enjoying the conference so far. Yeah? No? Okay. So we are going to talk about visual programming in JupyterLab using Blockly. So I'm Denisa, a robotics software developer at Quantstack, where I've been working for the past year and a half as a working student while also pursuing my studies in Germany. And he's Carlos, a scientific software developer at Quantstack, where he's been working for the past 4 years in a lot of the JupyterLab main features, such as the real-time collaboration one you saw yesterday. I'm going to start off with a table of contents so you know what to expect from our talk. First, we're going to briefly mention the motivation behind our extension. So what is visual programming, why do we need it, and how we can leverage it, as well as go deeper into the main features of JupyterLab-Blockly, its UI interface, and its Jupyter integration, as well as diving deeper into how you can build your own extensions on top of JupyterLab-Blockly, and finish up with some very cool robotics applications with 2 of the robots. So, without having to go into a very complicated definition, visual programming is essentially just programming without having to deal with specific syntax. So you don't have to worry about a mistab in Python or a missed semicolon or misplaced semicolon in C++ and get fixated on these sort of syntax errors that can be quite an impediment when you're a beginner. And you can just focus on developing your algorithmic thinking and learning fundamental programming concepts way faster, which is a very important part of course, early computer science education. Moreover, with this extension, we also aim to provide the smoother ramp of education for learners in the Jupyter ecosystem. So once you're familiar with the programming language that you're trying to learn, it's way easier to choose to just switch to a Jupyter notebook, for example, and start coding in that language instead of having to familiarize yourself with a completely new application. Our extension also offers a great tool for robotics prototyping, which we're going to show at the end of the presentation. So, JupyterLab-Blockly is an extension that uses interlocking graphical blocks, as you can see on the screen, to represent coding concepts. So the white canvas that you can see, the workspace, gives the user full creative freedom to be able to organize the blocks in the order that they want to and create the code that they want to in the specified language, in the chosen programming language, without having to worry in particular about the syntax requirements or errors that you'd normally get. The extension also uses the source library designed by Google, Blockly, which also has the same aim as us to make coding easier and more accessible through block-based visual programming. Now I'm going to let Carlos dive a bit deeper into the JupyterLab main features.
Thanks, Denisa. Does it work? No. No, in theory it's one for each, but no. Okay. So, yeah, so here you can see a demo, a small demo of JupyterLab-Blockly. Before starting to talk about JupyterLab-Blockly, the extension, I would like to do a recap of how JupyterLab extensions work. So most of you probably know already that when you develop an extension for JupyterLab, you can not only require plugins from other extensions, but you can also provide your own plugins. In this case, what we did with JupyterLab-Blockly is to so it extends a document file in JupyterLab, so you can store, users can store the workspace and continue with a new session later. And at the same time, we are providing a plugin, a token. So other extension authors can build on top of this extension. So the idea was basically to create a generic basic extension that provides you the workspace and the different blocks like the UI. So everyone can create new blocks on top of it. So for example, we already gave support to widgets on this new document type. And if someone wants, it's possible to create an extension where we define the blocks for IPy widgets, for example. And then users could create a block program where the output will be the widgets, and they can interact. The main components of the document are, first of all, the toolbox. As you can see on the left side, is the list of different blocks. It's organized by categories, and is what users can expand to find the different blocks and drag and drop them into the workspace. We also have a drop down on the top right side of the document on the toolbar where where it says default. That's the default toolbox. If someone wants to create an extension that registers more toolboxes, they will appear in that drop-down, so users can select. For example, we created multiple extensions for robotics. You can see the Lego Boost over there. For those extensions, we register new toolboxes, and you can then select it from there. At the same time, we have a drop-down to select the kernel where you want to execute the program. What we did in this regard is Blockly the library offers already different generators by default. Generators are the part of the library that transpiles from blocks to the specific code that will be executed. In this case, what we did is we took advantage of those generators using the language name, and we linked it to different kernels. So when by default, for example, we have Lua, JavaScript, and Python. When you install JupyterLab-Blockly, if you install any kernel with JavaScript, for Python, or for Lua, they will appear there. Any other kernel for other languages that you install, they will not appear there because we don't have generators for them. But any one of you can create an extension to register the generators and the blocks for that language. And then when you install a kernel for that language, it will appear there. Now, moving on into the output, basically what we did is to make it more simple, we reuse the code shell from a notebook. That way, as I said before, we can take advantage of widgets. We could create an extension to show widgets there. And at the same time, we believe it's very important for beginners to not only create the program with blocks, but be able to see the output, be able to see the code they are generating. That way, they can familiarize with the code. And and at the same time, they can see the output in the same cell. So the integration between the Blockly library and JupyterLab was quite smooth, actually, because there is a lot of different features that overlap or complement each other. For example, as I was talking before, we have generators and kernels. We use the generator to generate the code, and then we use the kernel to do the execution. On the other side, we can reuse components from JupyterLab to, for example, the code shell to make it implement the extension faster and see the code and be able to, we don't have to implement the whole kernel protocol. The code shell already implements the execute method that we can use to execute that code and receive the output. Apart from that, we have two key features that they actually overlap between Blockly and JupyterLab. For example, the theme. The library Blockly allows to create and customize your own theme. What we did in this case is to just use the CSS variables from JupyterLab. That way, whenever a user installs any theme, it automatically works in Blockly. And it's the same for translations. We took the list of different languages that Blockly supports, and we are listening for the language in JupyterLab, and whenever the user changes the language, we automatically update the language in Blockly. Well, as I've been saying all the time, everyone can extend it. What we did was to make it as generic as possible so other developers can build on top of it. To build on top of JupyterLab-Blockly is very simple. You can just start from the JupyterLab cookie cutter. It's like creating a normal extension for JupyterLab, but in this case, what we do is once you create this basic extension from the cookie cutter, you need to install the npm package JupyterLab-Blockly. Once you have the npm package, you can just require the token iBlockly registry, and then that's the API you will use to register new toolbox, new generators, or new blocks. Well, at the moment we have a small issue. Basically, the library Blockly uses a different, higher version of TypeScript than JupyterLab. So I'm talking right now about the Blockly extension for JupyterLab 3. In JupyterLab 4, that will come in a couple of weeks, we already updated the version of TypeScript, so this won't be necessary. Anyway, if someone wants to already create an extension for Blockly, the problem is that when building your extension, there is a small type error with one of the dependencies. It's already documented in the documentation of JupyterLab-Blockly in Real the docs, but yeah, basically you can create a patch to update that specific dependency. If any of you want to create an extension and has any doubt, you can also contact us and we'll help. Finally, once you create the extension, you of course need to require JupyterLab-Blockly to make sure that your extension, once you install it, Blockly is installed in JupyterLab. So you have you can require this token. And yeah, you can also use Conda for once it's done for shipping your extension. Well, I've been talking all the time about blocks, toolboxes, and generators. These are concepts from Blockly. Basically, the blocks are the main UI thingy that the user can drag and drop into the workspace, and they represent a special an action in the or like an addition, a function in the language that you are using. To create new blocks, there is two ways of doing it. You can use JSON format to define the different UI components for your code. For example, you might want to create an addition. That addition needs 2 inputs. You need to define that when creating your block. You need to specify that that block will have 2 inputs. After that, you can also create the blocks, define them using JavaScript. There is 2 ways of doing it. After that, we have the toolboxes. Toolboxes are just the list on the top left side of the extension of the document, sorry. And they are used to organize in different categories your blocks. And at the same time, is the way that's used for registering the blocks into Blockly. And finally, we have generators. Of course, you can define blocks, but at the same time that you define the block, you need to specify how that transpiles into the code. So you need to register using JavaScript a generator, a small function to generate the code for a specific block. And yes, basically this is the API that you can use from the token that we are providing in JupyterLab-Blockly to register as JSON objects or as a generator with the type generator from Blockly to register it into JupyterLab-Blockly. Well, as I commented before, we also created a few extensions for robotics. You can see the robot there, so now I'm going to let Denisa continue with the presentation and she will talk more about these extensions.
Thank you, Carlos. So as you mentioned, all of the steps that you need to take in order to create your own extension, now we're going to show our examples of creating some very cool robotics applications. So the extensions that we created are for two robots, the first one being the Nairo robot and the second being for the Lego Boost. The first extension that we created was specifically for the Nairo robots, and for those of you who are unfamiliar with them, they're just these 6-axis robots made for education, training, and in particular research and development, but adapted in the context of the Industry 4.0. So the extension itself offers two toolboxes in order to show the user this full compatibility with the Nairo 1 and NED 2 robots. You can see in Z2's implementation the Nairo 1 robot in action being controlled through the Blockly blocks that we have created for it specifically. In particular, each toolbox contains around 130 blocks organized in these 10 categories. So as you can see on the left side of the screen, we have blocks which not only control the movement, trajectories, and frames of the robotic arm itself, but you're also able to have blocks which control some of the other tools that come with the Nairo robot, such as the conveyor belt, the gripper, or the lettering. In particular, each block generates Python code using the functions from the PyNairo API. Now I'm going to show some demos of how this extension works. So once you drag and drop the specific blocks that you want and order them in the sequence that you want by just quickly connecting to the API of Nairo, you can just run the code and you'll be able to see the robot moving in the sequence that you have defined. And also in the up top video, you can see it working with the gripper, which is one of the tools that comes with Nairo. And you can define using the blocks very quickly the way that you want it to move and the sort of sequence that you want to perform. So after we accomplished and we published this extension, we went back to our original goal of creating extensions in JupyterLab aimed for education, and we thought how we could make these more accessible, also in terms of price range and in terms of how a beginner who's into programming can make it more interactive and more fun to start using it. This is how we came to the Lego Boost extension. So the Lego Robotics, this is based on the Lego Robotics set, which with the same blocks you can create 5 different types of robot. The one which we have used the most is Vernie, and you can also see him on the table as Carlos mentioned. And the main idea behind it is that you create a communication with the Move Hub, which is just a Bluetooth hardware piece, and in particular, it's the torso of the robot itself. And we pass commands through Bluetooth Low Energy Wireless Protocol, and all of the blocks generate Python code using the open source library PyLegoBoost. As you can see on the bottom of the screen, you can quickly connect to the robot itself, to the Lego Boost, by just looking into the settings of your computer or the device that you're using and taking the Bluetooth address of your specific Move Hub, and then you can just paste it into the connect function itself, in the connect block, and then define the sort of sequence of actions that you want your robot to perform. This can not only mean that you control its movements, but you're also able to control its LED colors and the colors that it shows, and also get some output from the sensor that it has, the distance and the color sensors. I'm also going to show now a demo of the Lego Boost in action. So now as we're running the program, the LED is blinking because it's searching for a connection. And once the connection is established, the LED becomes blue and the robot performs the sequence of actions that we have defined, at the end being able to disconnect and for you to define maybe another sequence and see what else you can do with it. Now, again, once we finished this extension and we did as most as we could do with it in that moment, we went back to our original goals of making it as easy as possible for beginners to start using it. So we thought, oh, wouldn't it be great to just also have a Jupyter-like deployment for it, so we can just send a link to someone and they wouldn't have to install anything and they'd just be able to test the Lego Boost on their laptop or on their device. For those of you who are unfamiliar with it, Jupyter-Lite is just a JupyterLab distribution, which just runs directly in the browser. And this is how we came with our latest project, the JupyterLab-Blockly IPy Lego Boost extension, which uses a web Bluetooth connection. And later we'd be able to deploy it in JupyterLite, and you'd be able to just connect to the robot using the link and control it with the blocks defined. As web Bluetooth is still quite experimental, the web Bluetooth API, in most browsers, we created this IPy Lego Boost library, which was coded by one of our colleagues, Torsten, on top of the Lego Boost browser library, but solving some of its previous issues and adapting it in particular to JupyterLab, and in the end creating this widget library that is able to control the Lego Boost. As you can see at the bottom of the screen, some of its blocks. This way it will be way easier and faster to connect to the Lego Boost, in the sense that you don't even have to look at the address of the Bluetooth as we previously mentioned. Once you first run a code and you want to connect to the Lego Boost, a pop-up window will appear at the top of the screen and you'll just have to pair once with the Move Hub, and then the connection is established and you're able to run the code quite easily. On top of this, we also were able to have two toolboxes. So on top of the main toolbox, which you can control the Lego Boost quite easily using Python, as previously mentioned, but with a web Bluetooth connection, we were also able to introduce ASIC Python. So that means that you're able to run tasks concurrently. So for example, if you want your Lego Boost to flash the LED in a certain sequence, you're also able to do this at the same time while moving it in a certain motion, like forward and then in a circle or whatever you want to do. So it won't just wait for the LED to stop blinking and then start moving, but it will do both tasks at the same time. So all of the source code for the extensions that we have mentioned can be available and seen on the Quantstack GitHub page. So feel free to give it a try and let us know what you think, and specifically also try to maybe build your own blocks and your own toolboxes on top of JupyterLab-Blockly. Thank you for your attention.
Thank you. We have time for questions from the audience.
Thanks for the interesting talk. One question, does it support ROS? Thanks.
At the moment,
Can you repeat the question? Just for the audio.
So there was a question from the audience if whether it can support ROS. So at this moment, we haven't worked specifically with controlling robots through ROS. So it would be a nice project and something to get into, and it would definitely be something that we'd like to do with maybe other robots, but so far this wasn't something that we worked specifically on.
I have two questions, if possible. Can users generate their own functions? So like from the code, from the blocks, encapsulate them in a new function and then reuse them?
Yes, that's a great question. So the question is whether, if I understand correctly, users can define their own functions but using the blocks. So actually, even in the main extension, the basic JupyterLab-Blockly extension, there are, on top of the already defined blocks, there are two categories. Either one in which you can define a new variable and you give the name of the variable, and then they offer you these four blocks in which you're able to either change the value of it or some basic interactions with it, and also a block in which you're able to define a function. So when you define a function, you have the freedom to define a name for it, also define how many outputs you want to have, the type of outputs you want to have, and inputs as well, and then you can use it later in anything you create in the same workspace to just call it later on and do what you have defined. There's also some demos on the JupyterLab-Blockly on the GitHub page, and they also show particularly how you can use variables and functions and all of the other things that you could do with the blocks.
If possible. A second question, is there a tool to translate from code to blocks? which I think could be also cool for.
Yeah, so the question is whether we have a tool to transform the code to blocks, and that's definitely something that we have discussed, and we would look forward into it, and we like to also work on that. That was one of the features that we'll probably go forward into.
We have time for a third question.
Hi, I was wondering, it seems you have like, there's Blockly and there's one Jupyter cell. Is it possible to have setup with like many cells and text and all that between them?
I'm sorry,
Like, is it possible to have something that's more like a notebook where you have a combination of like, here's a bit of code in Blockly, then there's some text, then there's some markdown?
Yeah. Actually, that's also.
Can you repeat the question? Sorry.
So, if I understood correctly, your question is about if some sort of a notebook with blocks, right? Yes, it's a project we're working on. Actually, Gabriela here is already looking into creating a demo, a mock-up of how it will look like, and we want to work on that. Yes.
Nicola, do you have a question still? No? Okay. Okay, last question there.
Yeah, I thought this was a really exciting project. So were you able to like work with any schools or do this in any educational settings yet? I'm just curious.
The question was whether we have tested this in schools, and I think it would definitely be something that we'd like to do. So far, once we have established the Blockly extension itself and we are satisfied with the features that we implemented, we started working more with the robots and regarding specifically the Lego boost, how we can make it more accessible. But once we also will be able to have the JupyterLab deployment, which will be very soon, which you'll be able to control the Lego boost just through the browser, so they won't have to install anything and they'll be able to test it faster. I think it would definitely be something we'd look forward to be able to also see people use it and get their feedback and be able to grow the extension.
So I want to thank you again for Denisa and kind of bad Carlos, right? So thank you, another round of applause.